620 meters underground, in the Bagala mine in central Sri Lanka, the air is thick, the light is a single cone from a headlamp, and the walls glitter faintly black. This is one of the deepest graphite mines on Earth, dug not with modern tunneling machines, but largely by hand, following veins of pure crystalline carbon that plunge at steep angles into the rock. Workers descend on wooden ladders bolted to shafts barely wide enough for a human body. It is hot, it is loud, and it is quite literally the source of the material that ends up shaved into curls on a classroom floor 8,000 miles away. But the story does not start here. It starts 3.5 centuries earlier in the hills of Cumbria in the north of England. Sometime around 1564. The exact year is disputed, but English record keepers place it in that decade. A storm in the Borrowdale Valley uprooted a massive oak tree near the village of Seathwaite. Beneath its roots, shepherds found a strange black substance. It was soft. It marked skin, cloth, sheep. Locals at first assumed it was a form of lead, which is why we still call the material inside a pencil lead today, even though it has never contained lead. It was, in fact, an unusually pure deposit of graphite, and it was unlike anything found anywhere else in the world at the time. For nearly 2 centuries, the Borrowdale mine would be the only significant known source of pure graphite on the planet. Think about that for a second. An entire global industry, writing, drafting, engineering, art, was built on rock pulled out of one valley in northern England. By the late 1500s, this graphite was being cut into sticks, wrapped in string or sheepskin to keep hands clean, and sold to merchants across Europe. This was the pencil in its rawest form. No wood casing yet, no factory production, just a lump of carbon and whatever the user had on hand to sharpen it. And that whatever was almost always a knife. For nearly 300 years, the pencil sharpener did not exist as a distinct object. It was a verb performed with a blade, by hand, badly, by nearly everyone who ever wrote. Move forward to 1795, Paris, in the middle of the French Revolutionary Wars. England, at war with France, cut off graphite exports entirely. A chemist named Nicolas Jacquani, working under pressure from the French military, developed a process of mixing powdered graphite with clay and firing it in a kiln. A technique that no longer depended on pure English graphite and, as a side effect, allowed manufacturers to control hardness by adjusting the clay ratio. This is still, essentially, how pencil cores are made today. Conti's innovation seemed like a wartime workaround. It was not. It was the moment the pencil became a mass-producible, standardized object. And a standardized object is exactly the kind of thing that eventually demands a standardized tool to sharpen it. That tool took its time arriving. For the first 3 decades of the 1800s, sharpening remained a private, informal, knife-based ritual. Then, in 1828, a Frenchman named Bernard Lassamon filed what is widely credited as the first patent for a mechanical pencil sharpening device, a small, hand-cranked apparatus using a rotating blade to shave the wood and graphite into a point. It looked crude by modern standards. It jammed constantly, but it was for the first time a machine built for one job only. Not carving furniture, not whittling toys, sharpening pencils, and nothing else. This decision seemed small at the time. It was not. Lassamon had just created an entirely new category of object, one that would eventually sit on tens of millions of school desks around the world. For the rest of the 19th century, pencil sharpeners existed mostly as novelties and workshop tools, patchy in adoption, inconsistent in design. Then, in 1897, in Fall River, Massachusetts, an African-American inventor named John Lee Love filed a patent for a small, portable sharpener he called the Love Sharpener. Love's design was elegantly simple. The pencil was inserted into a small, hollow, funnel-shaped block. A hand crank turned a blade around it, shaving the wood into a cone-shaped tip. The genius of it was portability. Earlier sharpeners were heavy, table-mounted contraptions. Love's device could fit in a coat pocket. It resembled, more than anything, the compact sharpeners still sold in stationery stores today. Love received U.S. Patent 594,114. He never became wealthy from it. Many black inventors of the era, working under a patent system that offered them little institutional support, sold their designs outright for modest sums rather than fight to retain royalties. His name largely disappeared from the story of the object he helped define. That is the quiet, uncomfortable footnote sitting underneath almost every everyday object history. Someone did the inventing, and someone else usually did the profiting. The 20th century is where the pencil sharpener stops being a curiosity and becomes an institution. In 1919, in Boston, Massachusetts, the Boston Pencil Sharpener Company was founded, and it would go on to manufacture the wall-mounted, hand-cranked sharpeners that came to define the American classroom for the better part of a century. That grinding, metallic sound, crank, 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 became one of the most universally recognized noises of 20th century childhood, right up there with the school bell. That same year, in Germany, a small manufacturer founded under the name that would eventually become KUM began producing precision sharpeners for architects and draftsmen. Engineering long, tapered points optimized not for classrooms, but for technical drawing. A reminder that this simple pencil sharpener was never really one object. It splintered early into professional tools and everyday tools, high-precision instruments, and cheap plastic novelties, and it never fully reunified. Then came a moment that had nothing to do with function at all. In 1933, the American industrial designer Raymond Loewy, the man who would later design the Coca-Cola vending machine, the Studebaker of Annie, and even NASA's Skylab interior, created a pencil sharpener as a pure design exercise. It was teardrop-shaped, chrome-plated, streamlined like a locomotive or an airplane fuselage, with no functional advantage over a basic mechanism. It never went into commercial production. It exists today in the collection of the Museum of Modern Art in New York, filed under industrial design, not stationary. Loewy's sharpener is one of the strangest artifacts in this whole story. A tool for shaving wood off a pencil, reimagined as a sculpture about speed and modernity, sitting in a glass case, never once used to sharpen an actual pencil. That is not something anyone made up. It is simply what happens when streamlined modern design philosophy collides with a 5-cent office supply. World War II disrupted almost every industry that touched wood, metal, and rubber, and pencil manufacturing was no exception. Cedar wood, the preferred casing material sourced heavily from California incense cedar forests, was diverted along with graphite and metal toward military production. Factories that once made pencil sharpeners retooled, like thousands of American manufacturers did, toward munitions components and military hardware. Graphite itself briefly became a strategic material for reasons that had nothing to do with pencils at all. The same year the war intensified, in December 1942, physicist Enrico Fermi and his team at the University of Chicago achieved the first sustained nuclear chain reaction inside a reactor built substantially out of graphite blocks, used as a neutron moderator. For a few wartime years, the humble mineral scraped out of Sri Lankan and Mexican mines was simultaneously destined for pencil tips and for the architecture of the atomic age. Nobody sharpening a pencil in 1943 had any idea they were holding a sliver of the same material sitting inside a nuclear pile in Chicago. This decision, treating graphite as a dual-use strategic resource, seemed like a wartime footnote. It was not. It permanently changed how governments classified and stockpiled the mineral going forward. After the war, the object entered its golden, boring, ubiquitous age. Electric pencil sharpeners, developing through the 1940s and 1950s, moved from novelty to standard equipment. By the 1960s, an electric sharpener mounted on the wall or sitting on a teacher's desk was close to universal in American schools, and the specific whirring hum of an electric motor grinding down a number 2 pencil became, for an entire generation, the background soundtrack of test days. Grind, grind, grind. 3 seconds, and the anxiety of an exam sharpened right along with the pencil. Behind the finished object, though, sat the part of the story that rarely makes it into classroom conversation: the mining. Sri Lanka has been a major global source of natural flake and vein graphite since roughly 1675, and by the 19th and 20th centuries, its mines, including Bagala and Kahatagaha, were among the deepest and most labor-intensive mineral operations in the world, some descending well over half a kilometer using narrow shafts and hand tools long after mechanized alternatives existed elsewhere. Wages were low, ventilation was poor, cave-ins were a persistent, documented risk. Meanwhile, in the United States, the cedar forests that supplied pencil casings were logged aggressively enough that by the mid-20th century, manufacturers were actively searching for substitute woods, eventually turning to incense cedar, farmed specifically for pencil production because the old growth supply had thinned. The pencil sharpener, sitting cheerfully on a child's desk, sat at the end of a supply chain involving deep shaft mining in South Asia and industrial forestry in California. Two extraction economies most users never thought about, connected by a 5-inch stick of wood and clay. Now bring it to today. Roughly 14 billion pencils are manufactured globally every year, according to industry estimates from pencil manufacturers' associations. A number so large is almost meaningless until you picture it stacked end to end, circling the earth several times over. Every one of those pencils will, eventually, need sharpening, and the global market for pencil sharpeners themselves is valued in the hundreds of millions of dollars annually, spread across manual handheld models, electric desktop units, and industrial-grade sharpeners used in architecture and drafting firms. Most of those sharpeners today are made of injection molded plastic, produced by the millions, used for a school year or two, and then discarded, a genuinely staggering volume of small, hard-to-recycle plastic and steel objects entering landfills every single year. Almost none of it tracked, almost none of it recovered. And here is the twist nobody expects. The pencil sharpener's most famous modern rival was born, of all places, in outer space. In the early years of American spaceflight, NASA astronauts actually used ordinary pencils in orbit, mechanical pencils, initially at a reported cost that became a minor scandal in the press when journalists discovered the space agency had paid over $100 per unit for a batch of custom mechanical pencils in the mid-1960s. But wooden pencils brought their own hazard. In zero-gravity, graphite dust, and which shavings do not fall to the floor and stay there. They float. They drift into electrical panels, breathing spaces, sensitive instruments. A stray shaving from a pencil sharpener, harmless on Earth, was a genuine fire and equipment risk on a spacecraft. That practical problem is a large part of why the Fisher Space Pen, a pressurized, gravity-independent writing tool developed independently by inventor Paul Fisher, eventually became the preferred writing instrument for NASA and, later, the Soviet space program as well. The pencil sharpener, in other words, helped write itself out of the future of space exploration, one stray curl of graphite dust at a time. So it became a knife trick, and then a French wartime workaround, and then a Massachusetts factory product, and then a museum sculpture, and then a strategic wartime material, and then a background classroom hum that an entire generation can still recognize with their eyes closed. Consider for a moment that a device meant to shave curls of wood off a stick of clay and carbon has been reinvented over and over and over by revolutionaries, industrial designers, nuclear physicists, raw materials, and NASA engineers. That is not something anyone made up. In the end, it is worth sitting with the sheer improbability of it all. A storm that uprooted a tree in northern England 460 years ago somehow led, through war, patents, deep mining, and a chrome sculpture in a New York museum, to a small plastic object sitting in the bottom of a child's pencil case right now, doing a 5-second job nobody ever thinks twice about. If you enjoyed this, hit subscribe and drop a comment telling us which part of the pencil sharpener's history surprised you the most. And make sure to like this video so more people can find it.